Hi everyone, welcome to section 1.3 of Math 9. This is Exponent Laws, Multiplying and Dividing Powers. So this is one of my favorite sections, and I know that some of you are laughing at me because I say that like every other lesson or something, but this one really is one of my favorites because I just think it's so cool what you can do with exponents. Okay, example 1, write as a single exponent and then evaluate. So if we do this using repeated multiplication, what we have is 4 cubed. So I've got 4 cubed times 4 to the 5th. So if I expand that, that's 4 times 4 times 4. There's my 4 cubed. And I multiply that by 4 times 4 times 4 times 4 times 4. And I used an X for times in the middle here to separate out the two pieces. But if I just gave you that and I said write that as an exponent, you would go, well, they all have the same base, which is 4, and there's 1, 2, 3, 4, 5, 6, 7, 8. So this is 4 to the 8. So there we have our single exponent. So that's what's meant by a single exponent, okay? And then evaluate means what does it equal? And to do that, you put that in your calculator. And some calculators have like an X to the Y button. Some have a Y to the X button. I don't know why. Those are different. So what you would do is you'd hit the 4 and then the X to the Y and then the 8 and then the equals. Or you could have the Y to the X button, or you have it's called a carré, but I call it the little hat because that's what it looks like. So whatever button of those is on your calculator, because you don't want to be going 4 times 4 times 4 times 4 times 4 and trying to count to 8. It might work with 8, but when it's 25, it's not going to work. So use the little hat button. Okay, so if you put that in your calculator, you get an answer of 65,536. And I'm going to put a box around that, and I'm going to label that as evaluation, because I want you to know what we're looking for when we ask you to evaluate or express as a single exponent. Okay, so that was cool. Now we're going to use the exponent laws. And the exponent law, which we can actually just, do you notice anything about that? Do you notice that the 3 plus the 5 equals 8? Well, that is actually the exponent law. So let's pop down to this lovely box here. And what it says is a to the m times a to the n equals a to the m plus n. Okay, so in words, when we're multiplying powers with the same base, which in this case is a, and that represents any number, any real number, we add the exponents to write the product as a single power. Okay, so we go m plus n is our exponent now. Okay, so if we go back and apply this to our example 1, 4 cubed times 4 to the 5th equals 4 to the 3 plus 5, which is 4 to the 8, which is the same thing we got before, luckily, thankfully. And that still equals 65,536. Okay, that's a pretty easy rule, and it makes sense, right? I always want the rules to make sense to you. Okay, when you are doing the homework, anything in this unit from here on, this is how you're supposed to do it. Okay, not this. Don't do this anymore. This is old. This is what you did in middle school. This is what you're doing now. You're applying the exponent rules. Okay. That's what I'm trying to teach you right now. All right, example 2, write as a single exponent, then evaluate. So this is going to be negative 5 squared times negative 5 cubed is negative 5 times negative 5, and then times negative 5 times negative 5 times negative 5, which is negative 5 in brackets to the power of 5, because there's 1, 2, 3, 4, 5 of them. Okay, that is it as a single exponent. You're going to leave the base the way it is unless there's a reason to change it. Okay, and if I evaluate this, it's going to equal negative 3,125. Okay. When you do this in your calculator, I would honestly, I wouldn't put the negative in, because I don't trust. Calculators actually are not consistent in how they manage the negatives. If you put the negative in brackets and you go like bracket negative 5 bracket to the power of 5, it will give you this answer. But sometimes where the negative is, the calculators work differently. I personally, I'm going to look at this. I'm going to go, there's an odd number of negatives. It's going to be an odd number. So I'm going to go 5 to the 5 and stick a negative in front of it when I write it down. That's just personally how I do it. Anyway, if we use the exponent laws to do this, we have negative 5 squared times negative 5 cubed. That's going to equal negative 5 in brackets to the 2 plus 3, which equals negative 5 in brackets to the power of 5. Okay. Now, this does, so just to be clear, this is the answer. This is the answer here. Okay. This is the answer. But it does also equal negative 5 to the 5th without brackets. Because it's an odd number of negatives, that does work. And it is sometimes helpful to change the base, or the sign of the base. So I'm just going to write that down here. Sometimes it's helpful to change the sign of the base, which is what we did right here. Yeah, we changed it from negative 5 to positive 5. That's the base. And then we just made this negative so they were equivalent. And then there's going to be an arrow going down because I want you to add a note to that when we get down there. Okay? I'll just do it now. But don't change the base unless there's a reason to. Okay? Okay. So for example, in our question, example 2, there was no reason to change the base. Leave the base the way it is in the question. Okay. All right, your turn. Pause the video, do these 2, and then come back and check your answers. Okay, so this equals, I'm going to use the exponent laws, right? So it's going to be negative 3 in brackets to the 3 plus 5, which equals negative 3 in brackets to the 8, which equals 6,561. And it's positive because there's an even number of negatives because there's an exponent of 8. And then this one, this is going to equal m to the 3 plus 15 because the base is the same. I don't care what the base is. If the base is the same, the base is m for both of them, so I can add the exponents together. So this is m to the 18, but I can't evaluate it unless somebody tells me what m equals. Okay? All right, next page. Now we're going to look at dividing powers with the same base. So let's write this as repeated multiplication again. So if we're going to divide this, it's 2 to the 5 divided by 2 to the 4. But I'm going to write it as a fraction instead because that just makes more sense in this context. Makes more sense of what we're going to do with the numbers. So 2 to the 5 is 2 times 2 times 2 times 2 times 2. And this on 2 to the 4 is 2 times 2 times 2 times 2. Okay, so I'm going to go over to the side and do this the long way so that you understand why this is allowed. Okay, so 2 to the 5 over 2 to the 4 is 2 times 2 times 2 times 2 times 2 over 2 times 2 times 2 times 2. But I could write that as 2 over 2 times 2 over 2 times 2 over 2 times 2 over 2 times 2 over 1, right? Because if I started with this, I could write it as what's up top here, right? I could push it all together when you multiply. It's top times top times top times top over bottom times bottom times bottom times bottom, okay? And 2 divided by 2 equals 1. So this becomes 1 times 1 times 1 times 1 times 2, which equals 2. Okay, that's the long way of doing it. The short way, the way that you will do, because you're never going to write all that out, you just go, oh, those cancel, those cancel, those cancel, those cancel, and I'm left with just 2. So that's my answer. Okay, there you go. That's it. It's a single exponent and evaluate. You could put 2 to the 1 if you wanted to. I'm not going to be fussy about that. That's okay. But evaluation has to be just the 2. Okay, this is definitely the evaluate is just the 2. Okay. Using the exponent laws, if we were in class, I would ask you to guess. I'm hoping you're seeing when we do things with multiplication and division, they tend to be opposite, right? And when we did the multiplication, we added the exponents. So this time we're going to subtract the exponents. So what we get is that 2 to the 5 divided by 2 to the 4 equals 2 to the 5 minus 4, which is 2 to the 1, which is 2. Okay, wasn't that just so much easier? I think it was. Okay, let's do an example using negative bases. So I have negative 3 in brackets to the 6 divided by negative 3 in brackets to the power of 4. So this is negative 3 times 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 negative 3 divided by negative 3 times negative 3, negative 3, negative 3, and then I'm going to cancel things out. So 1 in the top, 1 in the bottom. Because they're multiplied, that's the shortcut for doing what I did up at the right here. And what I'm left with is negative 3 times negative 3, which is negative 3 in brackets squared, which equals 9. Okay? I'm just going to fix this little 4 here that looks like a 9 because of the way the tech works. All right, so now let's do it using the exponent laws. I've got negative 3 to the power of 6 divided by negative 3 to the power of 4. So my answer is negative 3 to the 6 minus 4, which is negative, oops, I'm getting ahead of myself here, negative 3 in brackets squared, which is 9. Same thing we got before. Okay? Dividing powers, let's write the rule out. We're going to do it with letters standing in front, we're variables instead of numbers because the rule works for any real numbers. So a to the power of m divided by a to the power of n. So that's a to any real number exponent divided by a to any other real number exponent. And then I like to write it as a to the m over a to the n to remind you that those both mean the same thing and also to remind you about how the canceling works. Okay, and that equals a to the m minus n. Okay, take a minute, pause the video, take a minute, do these questions, and then come back and check your answers. Okay, so we're going to use the exponent rules. So that's negative 7 to the 5 minus 3, which is negative 7 squared, which equals 49. And p to the 25 divided by p to the 10 is p to the 25 minus 10, which is p to the 15. And we can't evaluate because we don't know what p is, but we can do that as a single exponent. Okay, next page. Let's look at some common mistakes that happen because they're really easy to do and you need to be aware of them so you don't make them yourself. Okay, example 1. What happened here is that the person who did this multiplied the bases together and added the exponents. So the adding the exponents is right, but this 4 is wrong. This should not be 4. Okay. This does equal this, but neither of them equals what starts with. All right, here they multiplied the bases and multiplied the powers, so that's wrong. Here they multiplied the exponents instead of adding them. That should be added. So this should be 2 to the 3 times 2 to the 4 should equal 2 to the 3 plus 4 equals 2 to the 7. That would be the correct answer there. And looking at some division questions, they divided 8 divided by 2 instead of subtracting. And here it looks like they did the 3 divided by 3 and reduced that to 1. And then they subtracted the exponent, so that the exponents are right this time, but the base is wrong. And this time they did both. They reduced the base and divided the exponent, so those are all wrong. The correct answer would be that 3 to the 8 over 3 squared is 3 to the 8 minus 2 equals 3 to the 6. Okay. And this one, the problem here is that this base and this base are not the same. So you can't just combine them that way. All right. What you can do, we'll actually just look at the next examples because I've got a couple of examples of combining things like this. So let's look at this. So example 1 is like example 7 above, 1a. So we have, it says to express it as a single exponent, and we can't do that directly because the bases are different. So what we need to do is change the base on one of them. And I don't know about you, but I'm always going to get rid of the negative and have it positive because that just makes more sense to me. So I know that negative 2 to the 5 is going to end up with a negative value. So that's going to be the same as negative 2 to the 5 without the brackets because it's got an odd number of negatives. So it'll end up with a negative value. And this is times 2 cubed. And maybe it helps to think of this as negative 1 times 2 to the 5 times 2 cubed. And then it equals negative 2. We're multiplying, so we're going to add the exponents. So it's negative 2 to the 8. Okay, that's as the exponent, and when we evaluate it, that's going to be negative 256. Okay. So this is an example where changing the base does make sense. There's a reason to in this context. Okay, so let's do a similar question with the with B, with division. So the same thing. I wanted to have them the same base, and this time negative 3 in brackets to the power of 8 is the same as 3 to the 8 because it is going to end up with a positive value. So that's going to be 3 to the 8 over 3 to the 4. Which is going to be 3 to the 8 minus 4, which is 3 to the 4. So I'm going to pause for a moment and I'm going to ask you to listen to my advice. While you're learning this, while you're doing the practice, write this step. Write this step, okay? What you write, you remember, all right? If you just skip that step and do it in your head or just whatever, you're much less likely to remember it. Okay, it doesn't take very long. I want you to remember this. That's because now you're expected to know it forevermore, any math you ever do. Okay. All right, example C. We have not learned any way to combine exponents with a minus sign or a plus sign, and in fact there is not a way to do it. So this becomes an order of operations question, except we're going to leave it as an exponent till the end. So we cannot do anything with the 2 to the 7, but we can combine the 2 to the 2 squared times 2 cubed. So this becomes minus 2 to the 2 plus 3, which then equals 2 to the 7 minus 2 to the 5. So there is my answer as an exponent. That's the simplest I can do it as an exponent. And I will warn you, there are going to be questions that say to do something that it's not possible to do, because we want you recognizing that you can't do it. Okay. All right. And then I need to evaluate this, so I'm going to plug this in my calculator. 2 to the 7 is 128, and 2 to the 5 is 32. So that if I subtract that, that equals 96. But there is no shortcut, there's no rules for subtracting powers with the same base. Okay. All right, last example, D. The trick here is to remember that this 3 here actually has an invisible 1 there, right? 3 is 3 to the 1. So 3 to the 1 times 3 to the 4 is 3 to the 1 plus 4, plus, and this is a division question, so this is 3 to the 5 minus 2. So this becomes 3 to the 5 plus 3 cubed, which again, there are no rules that let me combine those as exponents. So that is my answer as simplest exponents. And I can evaluate it using my calculator. It's 243 plus 27, which equals 270. So if when I'm asked to evaluate it, that is my answer evaluating it. And here, and here, and I see that I forgot to do it up here. This is actually 81. Okay, all right, that is the end of the exponents 1.3. And so go and do, oh, there's some homework, there's some practice right here in your notes. So do this practicing, and then there's more in your home. So there's some multiplying practice, and then some practice in the textbook. There's some dividing practice here. There's some dividing practice in the textbook, and I think that in the dividing section there's some mixes of multiplying and some combining things. All right, go have fun. We'll see you in the next video. Bye.